Great to be here at NOAH for the third time. I'm going to tell you a bit about the story of Optibus and why we do this by telling you about challenges that cities are facing in transportation and how they're solving this, how we are trying to solve this today. So when you think about great cities, what do you think of? Lots of people moving around, lots of meeting happens, people going to work, people going to school, tourist attractions, so on. Right? The way in which people move in cities has changed and evolved over time, but mobility has remained a constant factor of cities. In many cities around the world, it's what defines cities today. My name is Amos. I'm co-founder and CEO of Optibus. I founded the company 5 years ago with the understanding that cities are growing and millions of people are moving into cities, and we'll talk about that. And we don't yet have an efficient way of moving people around. We were really drawn into the mathematical challenge coming from a math background of optimizing transportation network in cities. It's really a complex problem. It's an easy problem to say and present, but it's really complex to solve. But I think there's like a huge reward in the end. If you optimize transportation, and we'll talk about it in the presentation, you basically affect millions of people around the world. So cities are growing. This map shows you how many people are living in urban areas, living in cities, versus rural areas. And you can see it from the 1950s till these days and going forward. The red represent the urban areas. So you can see that the map becoming more and more red. Just 50, 70 years ago, most of the world was rural. And today, most of the world is urban. And if we go into the future, almost all of the world will be urbanized. Now, just to put it into perspective and scale, it's not that we're talking about hundreds of thousands of people moving into cities. It's not even millions of people moving into cities, it's billions of people. Think about it, billions of people moving into cities just in the last 50, 70 years or so. It's a huge, huge demographic change that we need to be prepared for. Now, moving into cities is actually a good thing for the world. Research shows us that population density leads to productivity. I put it in simple terms, you put people together, you put them close to each other, close to jobs, and great things happen. They're becoming more productive. So that's really good for the world that we're moving people into cities, but it really causes one major challenge that we still need to solve, and that's congestion. The main issue is that we have millions of people moving into cities, and cities are growing, but the land is pretty much stays fixed. So we need to find an efficient way of moving all these people in fixed land while the city is growing. Now, these are the current ways that we have of moving people in cities. They can use their car, they can use a bus, they can walk, they can bike. What's the most efficient way? What will be a way that will be sustainable for cities going many years into the future? Let's look about walking. Walking is actually quite efficient. It's moved 9,000 people an hour. It's much more efficient than a car, for example. So in a way, if we put everyone in the city just to walk, and that's what we'll do in terms of all of the mobility needs, we won't have any congestion, and the land will be enough to carry on millions and millions of people. But we can't really have everyone walk in cities, right? We can't even have them bike everywhere in cities. So we need a better way. We can use cars. If we have everyone in cars, they can go anywhere they want. But car is the least efficient mode of transportation. It carries 600 to 600 people an hour, roughly. Basically means that if you put everyone in the city using private cars, we're going to be in one huge gridlock, which many cities already today, like LA and others, already have it today. So cars, actually, it's not only that we don't have enough space to move them, but we actually don't even have enough space to park them. Today, we have 5x more parking spots than we have households. I'll give you one example from Seattle, which I think is quite shocking. If you look at the real estate cost of parking, so think about taking a parking space, it consume space in the city, space that we can use to buy buildings and businesses and so on. We look at that cost. So it turns out the cost of parking in Seattle per household is about $120,000 a year. Think about it for a second. If we remove all private cars from Seattle, just as for this example, we remove all parking spaces and we somehow provide different mobility options for everyone, we can, in theory, give $120,000 for each household in Seattle every year. Yeah, it's crazy to think about the real cost of the private car. So what's the most efficient way of moving people in cities? It turns out we already have a good way, and that's mass transit. It was designed to move as many people as we can in limited land. It can move 10,000 to 20,000 people per hour, much more than any other means. And it's actually already quite a large industry. It's about $1 trillion industry worldwide. We actually think this industry is going to grow much more than it is today, mainly because many cities will start realizing that they can't really rely on the other modes of transportation, need to invest in an efficient and sustainable ways. So we have a good option that removes congestion, but we still see those empty buses. And if we look at the US, only 5% of the population is using public transit. So we have a good way in theory, but people are not using it much. And why is that? So when we founded Optibus, we looked at many different cities in the world, and we thought there is a good way of moving people, which is mass transit. How do we apply it in an efficient way to cities? How are the ways that cities are currently planning the transportation networks? And we thought there has to be some supercomputer somewhere in the city backend servers somewhere that looking at all the data in the cities and is building all these networks, buses, rail, and so on. It turns out after we visited city after city that the way that they actually plan transportation didn't really change in the last 100 years or so. So we took some pictures. This is the picture of one of our clients. It's a wall hanging on, it's a board hanging on a wall with pieces of papers where people are just moving them around, and that's the way that they plan transportation in their city. They decide what every vehicle will do, drivers, and what will be the routes, and so on. So we moved to different cities in Europe. We took 2 different pictures from 2 different clients in Europe, 2 different cities. This city is using wood sticks on a wall, and this one is using paper. It's like, this is not 100 years ago, this is today. This is how cities are actually planning the transportation, public transportation. So we thought there has to be another way, and we looked into AI and optimization. We said, we have lots of data about where people move, about demand, about supply, about cost, about traffic. AI today is much stronger than it used to be in the past, and we can do machine learning algorithms that can learn from all this data, and using optimization algorithms to design the most efficient transportation network in a data-driven and automated way, and not in a manual, experience-based way. So meet Optibus. We are a 5-year-old company, about 100 employees today. We raise around $54 million for some of the best VCs in the world. And we are building a cloud engine for optimizing transportation. We are on a mission of optimizing transportation in every major city in the world, and we're already working with some of the largest and most complex transportation networks, including London, Los Angeles, Singapore, Washington, New York, and many others. Going back into the supercomputer that I talked about, in a way we're building that. It's not a supercomputer, it's more like a cloud engine. But think about looking at this city, this is London in this example, watching all the demand and where people wants to go from and to, and what are the available space and supply that we have, and optimizing transportation for the city, for the public transportation, so the buses and trains and rail and all that, deciding what will be the routes, what will be the stops, what will be the timetable, and how to take people in an efficient way, in an automated cloud engine, AI-based way in the city. Thank you, everyone. If you want to read more, it was a very short presentation, so you can go to optibus.com. I'm also here today. Thank you.